Welcome to Lesson 2, Write Equations and Make Predictions. Our objectives are to use and monthly depreciation to write a linear model. So in other words, you're going to take what you learned last lesson and use it to help you write a linear equation. You're also going to use your model to make predictions about depreciation and vehicle value in the future. So let's look back at these graphs that we saw last time. We're looking at the straight line method. You'll notice that if we look at this graph, at year 0, we have a complete value of this item of $1,000. So we start at the purchase price. And then after 2 years, if we follow this up, you can see that the item is now worth $800. So we basically depreciated $200 every 2 years, or $100 every year, according to this graph. And that pattern will continue all the way down the graph. So what we plan to do is build a linear equation in y equals mx plus b form, slope-intercept form, in order to model this depreciation. Let's get started. Here we have our linear equation, y equals mx plus b. That is a standard linear equation in slope-intercept form. But let's go ahead and define these variables, especially for something like depreciation. So we'll make it specific to that. All right, so we have m first. Think about what m always equals. M in math terms is always our slope. So that's our rate of increase or our rate of decrease. So if we think about it in terms of depreciation, what is increasing and what is decreasing? Well, depreciation is causing our value to decrease. So our slope is always going to be the depreciation amount per year. That is how much our value is going to go down every year. That's our decrease to value. So again, let's look back at this. Notice that we started at 1,000. What's causing our value to go down every year? Well, the depreciation is causing the value to go down every year. So our slope here represents the amount of depreciation that we are taking off the value each year. So m is our slope or depreciation. So what is b then? Well, think back to your math knowledge. B is always our starting point, which represents the y-intercept. If we look back at our graph, back here, what does this y-intercept represent? What is this? So our y-intercept is at 0, 1,000. What does that 1,000 represent? That 1,000 represents the cost of the vehicle, the starting point, the initial cost of the vehicle before any time has gone by. So, writing it in terms of depreciation, this is our asset cost or our vehicle cost. Okay, now let's look at y and x. If we think about our graph, this is our y-axis, this is our x-axis. What does x represent? And down here you can see that it says year of life. So this represents our useful life, the years. What does our y represent? And here it says the value of the item. As we know, we just stated the y-intercept was the initial cost. So our y values represent the cost of our item. The y value is the cost of our item. And the x-axis is the year of life, or the useful life, or years. So let's go ahead and put that into words. So the y value is going to represent the value of the vehicle or the asset. And the x-axis represents years or useful life. Okay, so make sure that you write this in your notes, including the equation y equals mx plus b, so that you can refer to it when you need it. Let's look at an example. Delia purchased a new car for $25,350. This make and model straight line depreciates to 3,000 after 6 years. We need to write a linear equation to model the value of the car over its useful life. Well, we know the equation is going to be in this form. Y equals mx plus b. We can already fill the b in because we already know, if we look back, b, the vehicle cost, we know that. So we can fill in y equals mx plus 25,350. That's our vehicle cost. What we don't know is m. M is our depreciation. It's our annual depreciation. We're going to have to apply what we learned in the last lesson to help us find our depreciation per year. So if we have a vehicle that we purchased for $25,350, we know that we need to subtract off the salvage value of $3,000 and divide that by its useful life of 6. So if we take 25,350 minus 3,000, we get 22,350, and if we divide that by 6, we get $3,725. That is our annual depreciation. So we know that that is going to represent M. Okay, now when we fill it in for M, do we write it like this? 3,725x plus 25,350. Do I write it like that? Think about what would happen if I wrote it like this. If we had 1 year, I would multiply 3,725 times 1 and then add it to 25,350. Do I want to add depreciation or subtract? Hopefully you said subtract. So we need to always have a minus here because we are going to take the accumulated depreciation and we're going to always subtract it from our asset cost. Okay, here is our linear model that represents the car over its useful life. Let's try another example. In this example, a motorcycle purchased for $17,200 has a salvage value of 0. So this time it actually does have a salvage value of 0 and a useful life of 10 years. We want to write a linear equation to model the value of the car, in this situation this would be a motorcycle, over its useful life. And then we want to determine the value of the motorcycle after 6 years. So once again, we can use our formula y equals mx plus b. And we know b. We can fill in the b because b is the cost of the motorcycle. So we have y equals mx plus 17,200. Now, just like the last time, we need to figure out our depreciation. So we've got a motorcycle that we paid $17,200 for, but there is no salvage value, so minus 0 over 10 years. If we divide this, we get 1,720 every year. That's going to be our depreciation. So we have y equals negative $1,720 x plus 17,200. Now remember, this is where x and y come into play. X is our years and y is our value after those years. So if we want to determine the value of the motorcycle after 6 years, what do we need to do with that 6? Well, always go back to think about what x and y means. X means years. So if we plug in a 6 right there for years and multiply it by the 1,720 and then subtract that from 17,200, we should be able to find y, which is going to be the value of our motorcycle after that time period. Okay, let's do that. So we have 1,720 times 6. So we're going to subtract 10,320 from 17,200. and we get a value of 6,880. So the value of our motorcycle is now 6,880. And that answers B. All right, let's try one more example. In this example, the straight line depreciation equation for a car can be modeled by this equation. So the equation is given to you. We want to answer some questions. Number 1, or A, what was the original price of the car? Well, we can look at this and know that the original price of the car is our y-intercept, which is B. So that would be $22,000. Then it says, how much value does the car lose per year? Well, we know that M here, which is our slope, represents the depreciation that goes away each year. And that value is 2,750. That's how much the car loses each year. Now we want to know, what is the car worth after 5 years? Well, just like the previous equation, we would need to plug in a 5 for x. So we're replacing x with 5, and then we're going to solve. When I put this in my calculator and I multiply 5 times the depreciation per year, I get total depreciation of 13,750. Now think about what that value represents. That's our accumulated depreciation. And when I subtract that from our original cost of 22,000, I get the book value at the end of 5 years. So that's how we answer C. How about D, the last one? And that should be a D. How many years will it take the car to totally depreciate? Well, if we're totally depreciating a vehicle, then at the end of 5 years, it has to be, well, at the end of, we don't know how many years, but at the end of however many years, that's what we're going to determine, the value will be 0. So where do we put that 0 in? Well, 0 represents the car's value. So let's go back and look at our graph. Well, here's the value of 1,000, and then after so many years it drops to 800, then 6, then 4, then 200, then 0 after 10 years. Here, look where the 0 is. The 0 is on the y-axis. So if we go back, we know then that y needs to be 0. So when our value is 0, how many years will it take for that value to be 0? Well, here's our equation. We don't know x. That's what we're trying to figure out. In the graph that we just looked at, that happened after 10 years. So how can we solve this for x? Well, let's go ahead and use our math and isolate x. In order to do that, we need to subtract 22,000 to the other side, and we're left with negative 22,000 now on this side equals negative 2750x. Our final step then would be to divide both sides by negative 2750 in order to isolate x. Okay, these cancel and we get x. Then on the left, 22,000 divided by 2750 gives us 8. So what does that 8 represent? When we're doing problems that represent contextual scenarios, we need to have labels on things. Well, this isn't $8, right? This is 8 years. So the car will depreciate down to 0 after 8 years. If we were to graph this, our graph would go all the way down here, but this would say 8. All right, that is the end of lesson 2. So hopefully, at this point, if we look at our objectives, you can use the cost and calculate the monthly depreciation from last lesson in order to write a linear model to represent our car value. And then you can use your model to make predictions about depreciation and vehicle value.